Hello everyone, welcome back to logicbinder. In this video, we shall discuss about ambiguity in context-free grammar. A context-free grammar is said to be ambiguous if there is at least one string in that language that can generate more than one parsed. Or you can tell if the string has multiple distinct leftmost or rightmost derivations, then also it is called as ambiguous grammar. See this example. E goes to E plus E, E goes to E star E, E goes to ID. It is a grammar which generates strings in plus and star. For this string ID plus ID star ID, you have two leftmost derivations. See here, I have started with E goes to E plus E, and here I have started with E goes to E star E, but derived the same string. That's why this grammar is called as ambiguous grammar. You can see the parse tree also. For the same derivation, the parse tree is this. For this derivation, the parse tree is this. Means you are getting two different parse tree for the same string. Means if you are getting for at least one string in that grammar, for that string if you are getting two leftmost derivation or more than two rightmost derivation or more than two parse tree, it is called as ambiguous. But which tree is correct? Means if you are getting two parse trees, the compiler may get confused to check the syntax with which tree. Okay. If it is having two parse tree, which tree I have to consider and which is the correct syntax, it may get confused. That's why we need only one parse tree. Means we need unambiguous grammar for the compiler. See here, which tree is correct here? Generally, in any language, star operator will have more precedence than plus operator. Means star must be performed first and then plus. Means the string is evaluated like this. First star and then plus. Means whatever the operator is at the lower level, that will be evaluated first and the next operator will be evaluated next. In these two parse trees, as star must be evaluated first, it must be at lower level. Here it is at higher level. That's why this parse tree is correct. Means you need to convert the given grammar into such a form so that you will get this parse tree, not this parse tree. How to do the conversion means how to remove the ambiguity, we shall see now. To remove the ambiguity, we have three steps. First one is by adding the precedence rules. What do you mean by precedence? It defines which operators have higher priority in a given expression. For examples, we know that multiplication is evaluated before addition, like that. Second rule, adding associative rules. Means this will specify the order of evaluation when operators have same precedence in an equation. Means something like this, ID plus ID plus ID. Which plus must be performed first? Actually, plus operator doesn't show the difference if you perform this plus or this plus first. But to have clarity, in most of the languages, plus is considered as left associative. Means first left plus is performed next and next second plus is performed. Into precedence, if you have any in this you have to perform star first and then plus next. Adding these rules, you need to rewrite the grammar so that the production rules are modified to ensure every valid string has only one parse tree. Each and every string in that grammar must have only one parse tree after removing the ambiguity. Let us consider the same example. E goes to E plus E, E goes to E star E, E goes to ID. This grammar already we have seen it is an ambiguous grammar. Let us try to remove the ambiguity from this grammar. First we shall consider the associativity of the operators. Here you are having plus and then star. For these two operators in most of the programming languages, the associativity is left associativity. Means the operation must be performed from left to right. If you are having two pluses in an equation, first leftmost plus is performed and then the preceding plus is performed. Similarly for star also. See here, if I take this string id plus id plus id for this grammar, you have two parse trees. Here E is having, in this tree E is having left associativity. See here, means you can write, see the derivation also, E plus E. Next this E is replaced, okay, E plus id and then id plus id plus id, okay. Next this one, E goes to E plus E, next E plus id and then E plus id and then id plus id plus id plus id, okay. Previously what I have told you, whatever the operator is at lower level, that operation is performed first. See here, this id plus id is performed first in this parse tree. Means the leftmost is performed first. Means plus is here left associated. Come here, E plus E, id plus E, last id plus id, last two ids are performed first. Means here plus is right associated. But what is the rule? Plus must be left associative. Means this parse tree is correct and this parse tree is not correct. If you want to assign the associativity, the tree must grow in the left direction only, left direction, not in the right direction. If you want to the tree to grow in left direction, what you have to do? The plus must be left associated. If you want to grow the tree in the left direction, means it must be left recursive. Means you have to take the grammar rules like this. See, you must remove the right recursion. E goes to E plus E or id. In this format you have to take. Next, what is the another operator you are having here? Star. For that also you have to take left recursion only. Suppose if I take some other non-terminal, it is f goes to f star id or id. But how to combine these two rules we shall see now. Before going to this step, what is left recursive? Left recursive means the LHS is equal to the leftmost symbol in the RHS. What is LHS here? E. What is leftmost symbol in this RHS? E. These two must be same. Then that production is called as left recursive. If you want left associativity, you have to consider left recursion. If you want right associativity, you need to consider right recursion. Right recursion means that LHS part will be equal to the rightmost symbol of the RHS. Now how to take the precedence? As I already told you, whatever the operator which is having higher precedence, that must come at the lower level. Means that production will come at the lower level. Which operator is first performed here? Star and then plus. Means plus operator will come first. Okay. See, why I have taken F here? I want E to be left recursive. Okay. This F is used to perform star. Okay, why I have taken T different symbol here? As I want only left star. As I want only left associativity for star, I have taken F here. Now, T goes to ID. Okay, by these productions, what we will get? See, if I derive from E, you will get E plus F. And from F you will get f plus f star t, and from this you will get id. But if you want to get here id and here id, what I have to take? E goes to f directly I have to take, and then f goes to t I have to take. See, now you will get id. Okay, by bypassing this, what you will get is, if you want to generate the strings which are only in star, you can go from E to F directly, and from F you can use F star T. Understood? If you want to directly generate only ID, only the string ID, you can go from E to F, F to T, and T to ID. That's why we have taken RF or T. This is the unambiguous grammar for the given grammar. Here you need to remember two things again. First one is associativity and then precedence. If you are considering associativity, if the operator is left associative, it must be left recursive. If the operator is right associativity, it must have right recursion. And then coming to precedence, whatever the operation having higher precedence, it must come at the lower level in the production rules. Star is at the lower level and plus is at the higher level. This is how to remove the ambiguity in this grammar. Now let us see one more grammar. Second grammar which am I considering is R goes to R plus R, R goes to R, R goes to R star, R goes to A or B or C. Which grammar it is? It is OR operation. Here it is concatenation operation. It is clean closure. Okay. Some grammar for regular expression simply. How to? First let us check whether this is ambiguous or not. See here. For A plus B star C, let me consider A plus BC means A plus B dot C. What you will get? R derives R plus R I am taking, R plus RR, and then here A plus RR, here A plus BR, A plus BC. Okay. Next, one more derivation we shall see. What am I taking? This time I will take RR. In this place of this R, I will take R plus R. Again, you will get A plus BC in several steps. Okay, see, for same string you are getting more than two leftmost derivations. If you consider the pass trees also, you will get different pass trees. See, for first derivation, what am I getting? R plus R, here RR, and then this one A, this one B, and this one C. For second one, what I have taken first? RR. This one I have replaced with, okay, R plus R, and this one with C, this one with A, and this one with B. You got different pass trees for the same string A plus BC. That's why this given grammar is ambiguous. How to remove the ambiguity in this grammar we shall see now. Now we shall apply the associative and precedence rule to remove the ambiguity from this grammar. You can see here plus and are having left associativity. Clean closure is not having any associativity as it is unary operator, and star is having higher precedence, and then and then plus. As plus is having the least precedence, first that production will appear first. And what about the associativity? It is left associative, means you need left recursion. You need to take left recursion and take some other new symbol here. And then which operation is performed having next least precedence? Dot. Let me take that. For dot also it is left associativity, means you need to take left recursion and take some other symbol, new symbol, and then you will perform clean closure. Here it doesn't matter whether it is right associative or left associative, because it is not having any associativity. You can take the same symbol also, no problem. T star, and at last T goes to A or B or C, and you need to bypass. Bypassing means take the new symbol here. What is the new symbol here? T. Yeah, no need to write this one. It is going to T goes to A or B or C. This is the unambiguous grammar for regular expression. Thank you for watching.